I need one more thing to introduce before I can do the complex version of this. And I want to show you something concrete before I jump to that. Let's go back to this. How many of you had this trig identity memorized before this class? Some of you. Let's say you didn't have it memorized. This is one advantage of this expression I can tell you right now. The complex exponentials makes all the trig identities you know obsolete. Because instead of memorizing these individual trig identities, all you can memorize is this complex exponential version of cosine and sine. Let me write this down. I think I don't need any of this. So let me use this space here to express what I mean. So let me just use an example of one trig identity. I guess I've written the cosine version there already. How many of you remember the sine angle addition formula? One. How many remember sine angle addition formula? Maybe half of you. So half of you don't remember sine angle addition formula. So sine angle addition formula is this. Sine of alpha plus minus beta is equal to sine of alpha cosine of beta plus minus sine of beta cosine of alpha. If you don't have this memorized and you go into an exam, you are kind of up a creek. This is not easy to derive unless you have it memorized. What I can tell you is that whatever calculation required this, you can do it using only this. This is what you have to remember, although if you forget it, it's pretty easy to derive. You can go from here and have this expression for cosine and sine. Cosine of theta, staring at this for a while, I realized this. I can take e to the I theta at e to the minus I theta. That'll, cosine is an even function, so it remains. Sine of minus theta, that minus gets pulled out, it's another function. So the sine theta terms cancel out. So cosine of theta would be e to the I theta plus e to the minus I theta over 2. Right? To make it clearer, in case you are not seeing it, you don't have to memorize it. It's e to the minus theta minus I theta is cosine of minus theta, but that's the same thing as cosine of theta. And it's a plus I sine of minus theta, but it's all the function, minus comes out, it's minus I sine theta. So it's a question of, all right, you have these two, how can you combine them to get cosine? Or if you want sine, sine would be this. Sine of theta is equal to e to the I theta minus e to the minus I theta over 2I. So this is the, it's not technically definition of cosine and sine, but you can almost take it to be. Any equation you have that involves sine and cosine, you can write it out this way and it'll be valid. Let me just do this one quickly. So let's say, so I have an expression that involves sine of added angles. Let's say I have an expression that involves sine of theta plus phi. I need to expand this out, but I don't remember this trig identity. This is what I can do. I can write this out using the complex exponential. Let me do that and see if I can simplify it at all. So when I do that, this is what I get. So e to the, this argument here, e to the I, argument theta and phi, theta plus phi minus e to the minus I, the same argument, theta plus phi over 2I. And I guess if I'm trying to get back to that, then it's, maybe that's not the best example. Well, let me show you what simplification you can do. So this is the thing that's nice about exponentials that you don't have with trig functions. With the exponentials, when you have something that looks like exponential of a plus b, how can you expand this out in a way that you can do other algebraic operations to it? Do you remember exponential algebra? Yeah, e to the a times e to the b. That's how you can separate a and b. I can do that here. So I can get this quantity is equal to e to the I theta times e to the I phi minus e to the minus I theta times e to the minus I phi. I guess over 2i, but let me do it here. Good? And once you have that, I guess here, what you probably need to do is a factor. So let's see, is there an easy factoring I can do? Sorry. I know what I can do. So it's algebraically a little bit complicated to go from here to there. Let's see. Sorry, this is not the best example. So if you just remember this and you want to check it, what you can do is you can do the same calculation here. And that'll do that. Sorry, that's not a good example.